Hey guys, Tori here from Overlook Horizon. Welcome back. It's Starship flight time. So that means we're going to come back here and cover a little live stream action here. I'm excited to see Starship fly again. Last time around was a little bit of a short flight time for us. We were in and out in a hurry because Flight 7, the upper Starship stage, didn't make it very far. Had a big boom. But we did see a successful booster landing or booster catch last time, so that was pretty exciting. So we're still excitement guaranteed either way today. So I'm pretty excited for this. I think we should be in store for something good today. I'm hoping that maybe it'll go a little bit longer than Flight 7 did. We're again launching at nighttime or evening time. It's not really nighttime really, but evening time. As opposed to a lot of the earlier flights, we were launching really super early in the morning, and then it was landing at nighttime. We could barely see the landing on camera, on video. So this time we're launching in the evening, and we should be landing in daylight by the time the mission happens here. So pretty excited for that. We should get some cool views. Hopefully, if Starship can make it that far this time. So we'll see what happens here. So hello to everybody checking in today. I was going through some of the chat as the intro was rolling. We saw Fairgrounds here with us. Said, hey, Tori, another flight mate. Excited for this. Donna, glad we're broadcasting. I try to get them when I can. It's a busy time of year. We're coming back to Overlook Horizon season, though. Wintertime is not the Overlook Horizon season. Schedule gets kind of busy in the wintertime, but we're coming out of winter. The groundhog is coming out. We're ready for spring and summer. And we can kind of hang out here a little bit more, hopefully. Let's see. Graham, one of our amazing moderators, is here with us as well. Mike says hi to me and all the others. John Clayton's watching over in the UK. Good to see you. Cheryl says hello. And Ryan says it's a go. So I'm excited here. We've still got a little more than an hour until launch time here. So we've got to go. SpaceX is going to go live about 40 minutes prior to launch. So we still have some time. They're probably not going to go live until their stream says 5:59 p.m. Eastern time. And right, and we'll put the date here. Or where does that go? Right here. So it's currently 5:23. So they were supposed to go live in like a little less than half an hour from now, but now it's like 40 minutes from now. So we'll see. They should be live soon, assuming that they don't push the launch a little bit. Last time, I think it got pushed a few minutes from Flight 7, if I recall correctly. Maybe like 20 minutes later from Flight 7. Going off of memory on that one. But yeah, hopefully we don't have any delays or anything like that today. We should be coming up on the fuel polling here. Or actually, it should be done. I haven't seen any updates on whether we're actually fueling the rocket at this point. I was getting the stream already, but propellant loading should be just about ready to begin on Starship and Super Heavy here any seconds. The actual LOX loading on Starship will begin here. Generally, it starts T-minus 45 minutes lately on the current most recent timelines. They used to do that a little bit earlier, but now we're T-minus 45 minutes. We start loading in liquid oxygen. Fuel goes in a couple minutes later at T-minus 42 minutes. Then the booster starts fueling T-minus 41 minutes. And then booster liquid oxygen is the last thing that gets loaded start loading into the vehicle as well. So all that'll start happening here. We still got about 20 minutes until that actually happens, but the fueling poll should be just about done, but no word on that I've seen yet. So we'll go through what the mission is today, what went wrong last time, what they're trying to do here today. We'll answer some questions. We'll say hello to everybody, and then hopefully we'll see a cool launch here in about an hour and 5 minutes. So not too long from now. Let's see. Let's check in with a couple more comments here. Graham says, "Dude, where's the beard?" I think you missed it. When we did Flight 7 in January, I didn't have the beard in January either. Pretty sure I didn't. The beard's gonna come back though. That'll be a spring return for the beard. So we'll see it again in the spring and summer streams. Zach, my friend Zach over at the launch pad says, let's go. Oh, overload the mic there. Good to see you, Zach. Thanks for stopping by. Nina says hello. TP Seeker. Oh my God, it's Tori. We missed you. I'm here. Let's see. Here we are again, says Web Chanter as well. Max is here. T. Brookie says you have to go see a Starship launch. It's worth the travel pain. Went to see Flight 6. So amazing. I would love to go down. I have yet to go down to Boca Chica. Just hasn't been in the cards yet for timing wise, but I would love to go down there and actually see a launch. You know, of course, I don't know, the travel, the actual travel itself, I'm not so worried about. The harder part is, this mission was scheduled on Friday. Now it's Saturday. We're a couple days later. We're, hopefully we launch today. It's possible that it doesn't launch today. So it's like kind of just sitting around going like, is it going? Is it not going? You never know. But I would love to go down there. Liam says, hopefully it all comes back down. Well, listen, it will. I can guarantee you that it will come back down. The question is, will it come back down in one piece? That's always the big question. Is it definitely will come back down. Starship Flight 7 came back down. Just came back down in a bazillion pieces. So it'll definitely come back down. Let's see. Hello from Norway. Hello, Norway as well. Wes Quiz, thanks for the super chat. Appreciate it. Just go, no booms. Yeah, hopefully we get a nice, smooth launch today. Silent says you're my go-to for launches. Well, I appreciate that. Silent listen. Victoria's glad we're back as well. Let's scroll a little bit as well, see if anybody else is here checking in, and then I'll go through what we're looking at for the mission here today. Oh, there's Red Scorpion, one of our amazing moderators as well. Almost forgot about us. Come on, Red. It's all right. He's here. He made it. He says, let's go. Terry, hello from down the 90 in Tonawanda. Glad you're on again. Well, hello from Tonawanda, or to Tonawanda. Tonawanda, for those that are not in the general area, is, I don't know, maybe like an hour and a half from where I am. Not too far away. Just in Tonawanda. Not too long ago, actually. Maybe like 2 weeks ago, I think it was in Tonawanda. Let's see. Zach, of course, agrees that traveling down to go see a Starship launch is totally worth it. Let's just, yeah, Zach also says, let's just not repeat the SN11 foggy launch. Yeah, in case anybody doesn't remember or got to go back to their bingo card. The SN11 launch, it was, we actually, I think it was, one of our moderators drew up like a line drawing of a Starship because during the pre-launch, SpaceX was live streaming it, but we could see nothing. It was just all fog. We're just staring at a white screen. And we were all kind of like, is it out there? We think it is. And then eventually it launched. And then, yeah, but it was, we didn't really get to see very much. Let's see. Build It Young says, what 3D printer did you use for your Starship model? So I got gifted this 3D model. So I did not actually do the printing of this. So I couldn't tell you, but I will tell you the company that did it is called More Than 3D. So they have a whole bunch of you can buy the actual like files to do the 3D printing yourself, but you can buy them pre-printed as well, I believe. But that got gifted to me a while ago by them. So I do have a 3D printer. I can 3D print. I don't know if I'm that super skilled enough to actually do something quite like that. I mean, I guess if I really tried hard, I could. I did. So here's my, let me get you in a different camera view here. Hold on. I'll switch you over to, let's see, we'll switch you to this view. So this is the one that got gifted to me, which is pretty amazing. Like, you know, obviously it's pretty huge, but not only that, like, I don't know, this is the stuff that like people are super creative that I'm like, how do you think of this stuff? But like on the inside, it has like fuel lines, but it also has these like little tiny magnets in here that like they just snap together, and then the whole thing holds like that, and you can take every section apart. This is an earlier version of the Starship, so the internals are not quite like this. Also doesn't have like the heat shield on it. This is like one of the very, very, very early on versions, but it was really cool for demonstrating early on because you could take it all apart. You could see header tanks, you could see fuel lines. I'm not sure if you could see that in there. Some fuel lines in there as well. And then of course, like the flaps were moving. Like early on in the Starship days, like everybody was wondering, like, what people were asking all the time, like, what exactly do the flaps do? Like, how does this work? What's the belly flop landing? You know, because, you know, the belly flop landing where we were coming down like this, you know, that was pretty wild at the time. People weren't really following it. So yeah, pretty awesome design. And then of course it's got like landing legs that actually like retract. There's actual engines down here as well. Like this model is pretty awesome. And this is one of like the very, very first models that More Than 3D did. And now the model is so much more advanced, and it's got all kinds of upgrades to it. So pretty awesome. If you're really, really into 3D printing, highly recommended. This is the model that I 3D printed. Just a little bit smaller. It has none of those features. This is a Crew Dragon capsule that has a trunk on it, and like that's it. It does nothing. It doesn't come apart or do anything. It's just, I didn't even paint it or anything like that. I mean, it's got, you know, some details to it, but yeah, that's about as good as I can do for 3D printing is that fit in the palm of your hand kind of 3D printing right there. Not quite as impressive as this guy. So anyways, there you go. There's a little bit on the 3D printing of the Starship. All right, let's see. Let's get back into it. We'll grab a couple more chat questions here as well. Yeah, Graham says just be careful with it. No drops again. Yeah, most of the time I end up... That's the other down... Like, the magnets are surprisingly strong on this thing. But... if you hold it the wrong way, like, they're pretty strong, like, pulling straight apart. But if it's, like, you give it a little shear force and push to the side a little... Let's see, I gotta get this on camera. You know, if I just pull like straight up, it's got a pretty strong pull, but if I just twist to the side a little bit, then it breaks pretty easily. And that's usually how I end up dropping it, is I bend it and then it falls apart in my hands here. All right, so let's get into what the actual mission is here for today. We'll switch over to where's the button that I'm looking for? We'll switch over to this view and we'll take a look at... Oh, I'm not on camera. Hello, I'm here. We'll take a look at what we're doing here for today. We're still 55 minutes away from launch. SpaceX will be live here in about 15 minutes, but obviously we're launching down here in Boca Chica, Texas, heading out over the Gulf of whatever we're calling this now. Over the Gulf. We're heading this direction. And you can see, it's actually really funny that I said this on the last stream because of what happened. For some reason, it's almost like it was meant to be, because for some reason, we were talking about the hazards last time. You can see the hazard zones that are highlighted in red here. And I talked about the last time, like, how we've got hazard zones for the booster, and then we've got this hazard corridor for the actual ship itself, and then it kind of dims out and gets pretty small as you get out here, and then it just kind of goes away, because as I said the last time, I was like, once I forget the exact wording I used, but we got to here and I said, once we get to about this point, the chances of failure are pretty small. You know, it's got to fail within like a certain second or two. And then, of course, that's exactly what happened. So I was like, what are the chances that this, I mean, Starship failed like right in this area. And then out here in Turks and Caicos is where some of the debris went. And it was kind of, you know, I mean, I don't think we had any like super hazardous debris, but debris was definitely falling down in Turks and Caicos. And so it was, yeah, not a great situation. Made for some pretty cool videos, but yeah, not a great situation to have debris falling on out on land. That's why we have these ocean corridors out here where we're trying to avoid as much land as possible. And for the most part, like there is no land in the corridor except for just this little area of like Turks and Caicos in here, like little tiny bits of land. And it's like, what are the chances that debris is going to land there? Like for debris to land there, it's got to have a mission failure right at the exact spot for debris to land there. Other than that, it's just all water. And then that's exactly what happened. Crazy. Hopefully we don't see that again. But anyways, we'll zoom in a little bit closer here just so you can see the booster action here. So obviously we've got Starship and Super Heavy will lift off. They'll start heading into orbit. You'll get the most engine cutoff. It's called MECO. It's not main engine cutoff. For Starship, it's referred to as most engine cutoff because they do hot staging, meaning that it'll actually separate while the engines are still on. And Starship will continue on into orbit, hopefully, or in suborbital trajectory, more accurately. And then the Super Heavy booster will spin around. It'll jettison the hot staging ring, and it'll start heading back. And initially, it's going to target the ocean. Always targets the ocean initially. You use those grid fins to start pushing it back a little bit, but it always targets the ocean. It's got to get a go. It's got to get a manual go from ground controllers to actually go for the catch attempt. And usually we get that right after the booster boost back burn shutdown. They give a go for the catch attempt. And if that's the case, then the grid fins will start pushing it a little bit closer to the landing sites. Then at that point, it will target not quite the tower yet. It'll target just short of the tower, just in case the engines don't relight. Then it will come back. It'll do an entry burn. It'll do a landing burn. And then during that landing burn, that's when it kind of does the final little slide over to the launch tower. And that's just to make sure that, you know, they're not going to damage the launch tower if something goes wrong at the last minute. So now during the last flights, obviously, like I said, there were some issues, and they're working on testing some of those things. They're also working on trying to do some of the objectives that they didn't get to do during Flight 7. So, you know, some of the main things that happened, you know, the booster itself did pretty well. Booster, all the engines ignited during the actual burn itself. We had the stage separation. Everything was great. During the boost back burn, they did lose one engine. So there was one of the engines did not ignite during the boost back burn. And that was because it had a low power igniter issue. So we lost one of those engines. But interestingly enough, when it did the entry burn, the engine came back on. Or maybe it was the landing burn that the engine burned, that the engine returned to normal. So, but they do have they're planning some igniter system upgrades for future flights to kind of make sure that engines reignite reliably. But that was kind of just a minor issue. They're also testing some additional radar system capabilities on the actual launch tower itself, trying to refine that, you know, make sure that they can really get pinpoint landings of the booster system. But it worked pretty well last time. So they've had 2 successful catches of the booster now at this point. Main issue last time was Starship itself. So after separation, all the engines ignited, everything was good. But then about 2 minutes in, there was a flash that was near one of the Raptor vacuum engines. They had a pressure rise in what's called the attic, which is a space it's an unpressurized space there that they started seeing pressure leaking into the attic, which is right above the engines there. And then the ventilation system could not vent that propellant leak. The gases that were being formed there couldn't vent that out fast enough. So it caused a fire in that area. And then we started having all kinds of things go wrong at that point. So it was about 8 minutes and 20 seconds into the flight that Starship was lost. So if we can make it past 8:20, we'll be in better shape today. Hopefully we make it all the way out to, I think it's an hour and 6 minutes after launch is when the planned splashdown is actually happening. So when SpaceX went back, they had to do their whole investigation. What they had found, some of the things they found were they had what they called harmonic vibrations in flight that were several times stronger than what they had seen in ground tests. Those vibrations kind of overstressed a lot of the components in the propulsion system, which is where we got those propellant leaks from. And then, so that was like the initial root cause, was those harmonic vibrations causing a propellant leak. Then you had kind of some sub failures, which is the propellant leak happened inside that attic area. The attic area ventilation system was not adequate enough to get those gases not to accumulate. And so once you kind of had this flammable buildup inside there, then the fires, you had fires erupt. We could actually see some flashes of fire on the video from the last flight. Those fires couldn't really be contained or put out. And so that ultimately, it's kind of the chain of events that led to our loss of Starship Flight 7. So it did, the flight termination system automatically triggered. So that's good. That's good news. The debris all fell within what's kind of considered the pre-planned debris area. So that's good news as well. There was some reports of debris landing in like Turks and Caicos, but I think it's nothing hazardous was really found or landed there. So didn't have any crazy significant environmental impacts. So not great, but not a horrendously terrible situation. So this time around, they've got upgraded feed lines for the Raptor vacuum engines to kind of handle those additional vibrations that they saw last time. They've changed some of the propellant temperatures to reduce stresses in the feed lines. They're also they've lowered their thrust target for the upper stage engines to try to account for that and reduce some of the vibrations as well. And they've added some ventilation to that attic area to try to vent any of those, any propellant leak that might happen, try to vent that out a little bit better so that they don't run into fires like that, uncontrolled fires. So, and then down the road, we're looking at some point, they'll start adding Raptor 3 engines in there. And they said that would actually reduce a lot of the leak prone joints because the Raptor 3 engine is a much more refined engine itself. So a lot of those leak prone joints from the propellant system would actually be eliminated once they start using Raptor 3 engines. So I guess continuing on with what the plan is for today, one of the main things that they're trying. Obviously, we're still going to go for a booster catch, right? We want to try to catch the booster. That's pretty exciting. That's kind of awesome. Got to try to get to that actual suborbital engine cutoff, get Starship in that suborbital trajectory. One of the main things they really want to test is this payload deployment system. So they tried last time. They're going to try again today, is to put 4 Starlink simulator satellites, deploy those when they're in that suborbital trajectory. So they're trying to demonstrate that Starship has the ability to release payloads, which is kind of critical to do because at some point, like if they can make Starship operational for at least deploying Starlink satellites, then now you've got like an actual business purpose mission that you could start to rapidly send flights up and continue your iterations on the actual vehicle design. So The other thing, they were going to do this on the last mission, didn't get to it, was a Raptor engine relight in space. Another super critical thing, that's generally simulating the deorbit burn.
It's going to deorbit.
And that's obviously super important. If you get this big giant Starship into orbit, it's got to deorbit safely.
Deorbit.
So they're going to perform that Raptor relight in space. Another essential thing that they wanted to get to last time, but they did not. They also have a ton of re-entry experiments. So they're testing more heat shield technology. So they've got a couple sections that have no heat shield tiles to intentionally stress unprotected areas. They've got some new metallic tiles. One of those is actively cooled to try to test some additional heat shielding technology or different types of ways that they could cool the vehicle and get it to survive. And then they also added some tapered tile edges to reduce some hot spots that we've seen in previous flights, especially around like the flap area, things like that. They've got, we've run into these hot spots, and that creates a problem because then we get burned through, and that kind of spreads, and you get hot gases going to areas where it's not supposed to be, causes a whole bunch of problems, obviously. So we want the vehicle to come back in one piece with, no holes in it at all. So a couple of those tests happening. They also added this on the last one, but they've got a ton of actual hardware and software upgrades to the vehicle as well. They changed. So we were looking earlier at my Starship model. These forward flaps here at the front, they've changed these. They're actually not even in this position anymore. So they've moved them. Let's see if I can come on. They've moved them forward, closer to the tip, and backwards to the leeward side of the vehicle to try to reduce some of those hot spots that we saw. Oh, see, there you go. I told you, we almost broke it. We almost broke it. Ooh, boy. Almost went into a million pieces. But they moved those forward flaps a little bit so that to try to reduce some of the burn through that we've seen on previous flights as well. The Starship also has some non-structural catch fittings. So in order to, they really got to sort out the re-entry bit first, but they need to test some of the re-entry capabilities of Starship catch fittings. So there's catch fittings on the actual Super Heavy booster, but at some point they're going to need to catch Starship or land Starship. So they're trying to figure out best way to do that. They're going to do a little bit of testing on that. And then we talked about some of the upgrades in the booster system as well. And hopefully we'll have a nice landing there. So I'll cover some weather in a minute, but I saw some chat going by. Somebody said, tagged me here. Pork Chop Jimmy says launch is now targeted for 5:45 Central Time. That would be like a 15-minute delay. Is that correct? If I recall correctly. Not that I don't trust you, but it's, trust but verify kind of thing. Yeah, there you go. Official tweet from SpaceX. Starship team is go for propellant loading, targeting 5:45 p.m. Central Time for liftoff of Starship's 8th flight test. So, what that means is we got to update our timeline here, which is somewhere on one of these monitors that I have. So we're now not 5:30, but 5:45. So it pushes us back a couple of minutes there. So nothing too drastic, but yeah, thanks for pinging me on that update there, because I get talking and I didn't see that. So appreciate that little update there. All right, let's go back. I missed a whole bunch of chat here. I was just kind of rambling on for a bit. Let's go back and see what some comments were in here, and then I'll go on to, we'll talk about like what weather looks like, and I'll show you the trajectory here for today. We started looking at some of the trajectory, but we'll show you the rest of it as well. Build It Young says, do you know when or if SpaceX attempts to catch Starship, not the booster? I mean, I think they're working on plans to potentially catch it as early as Flight 9, I think is what the last that I saw. But of course, a lot of that depends on what happens today. They really have to kind of sort out the reentry bits. So we've seen Starship come back a couple of times, mostly intact. Obviously, the very first time that it came back intact, it was like barely intact with the one flap that we saw on camera. Potentially, that thing was just barely holding on. But then even in the next flight that we saw come back intact, still a lot of burn through on the flaps. Not really ideal, especially like structurally, if you're going to put stresses on it to actually catch this thing. If part of it, even though maybe it survived and got all the way to the ground, if part of it is burned away, like you might have some structural integrity issues when you actually go to do that landing part. So they really got to sort that part out first. We have yet to see a Starship come back fully intact without some sort of damage to it. I mean, we've had some really great soft landings that looked fantastic and were pretty darn good. Just none of them were quite perfect yet without any damage. So they really got to get a little closer to perfection on that, but could be as early as Flight 9 where maybe they try to catch Starship. I don't know if that'll actually happen, but last I heard there were, potential talks of doing it as early as that. Nina wants to know, are the Starliner astronauts back? No, I think March 10th. I think it's March 10th they're coming back. Or no, March 10th is when Crew 10 launches. So then they would come back shortly after that. I think those are my dates. I think I got those dates correctly. So I don't know what the Crew 9 return date actually is. But I think Crew 10... Oh, no. Crew 10 is now March... Oh, that's Crew 10 docking. So Crew 10 itself... Let's see. Let me get my dates right. Crew 10 launch is now March 12th. Docking would be the 13th. And so Crew 9 should be coming back shortly after that. Let's see. So, somebody... Build It Young. Another question from Build It Young. How are they going to catch Starship in incoming launches? Won't the wings interfere? Well, so... It'll be interesting to see what they do. I mean, they've talked about using catch fittings for Starship, where they could catch it with the second tower that's at Boca Chica. Because there are two towers there, so one you can catch one booster with one, Starship with the other. We also saw, obviously during the testing, we saw Starship actually land with landing legs. But I think ideally they're trying to get rid of the landing legs and just catch Starship with the other tower and not landing it on the ground. So I think that's the plan as early as Flight 9. So does that mean a full orbit? Yeah, it would mean basically a full orbit. It might not technically be considered orbital if they just go around once, because you may still technically be suborbital, but mostly orbital. Pretty close to being orbital, unless they go around. If they can demonstrate the Raptor relight in space again, they might feel comfortable going up and doing a couple laps, and at that point it'd be considered orbital. Obviously it's in a stable orbit, but they could also do it suborbital in the sense that it's like almost to the point of being orbital, but has an automatic return just one full lap later. My chat jumped away from where I was scrolled. There was a good comment in here that I was gonna grab, but my chat just jumped away. Oh, there's a good one. Graham says you could pump out a whole lot more Starlink satellites. Yeah, if we get this Pez dispenser thing to work, you could definitely start pumping out some Starlink satellites with Starship launches, which would be pretty cool. I like this comment. Here's our little sales pitch, but from John. If you haven't initiated the like button yet, you deserve to have your Raptor fizzles come. Oh, all right. Well, thanks, John. Appreciate it. I think he's telling you to click the like button on the video. I think that's what he's trying to tell you. Wouldn't it make sense to change just one thing rather than a bunch of things? That way you know if the new thing breaks the ship. I mean, in theory, like in like very simple terms, yes, that's generally an easier way to do testing. But when you're talking about like a super complicated vehicle like Starship and Super Heavy, I mean, number one, there are so many things that they have to change that like you can't just go one by one. We're going to be here forever waiting for it to launch if you go one by one. But also, the vehicle is so advanced with so much monitoring and so many, I forget how many cameras are on it now, but there's a bazillion cameras on it. There's like 30-something cameras on it. There's so many monitors and sensors and things like that that, you really can see pretty well like how various aspects of the vehicle are performing. When you start to get into more advanced vehicles like that, it's like you can change multiple things and go like, yeah, well, this thing didn't work because we have sensors and cameras that just watched it fail. So yeah, in general, like smaller scale, changing one thing definitely makes sense. Change it, test it. That's just generally how I do a lot of the software engineering that I do for my real work. Changing one thing, testing it, and then going to it. But this is a pretty advanced vehicle with a lot of monitoring, so I think you can get away with changing multiple things. Framrick. Oh, hey, Framrick, one of our another awesome moderators. Do we think we'll see the Pez dispenser in action? I really hope so. I think that'll be pretty cool to actually see the Starlink simulator satellites deployed. I think we'll see them. I think they'll put them on camera. Obviously, I don't know for sure, but I think they would do it. I don't see why not. It's not really, I mean, there's a lot of stuff they don't show us because of like proprietary information, but I don't see why they wouldn't show the Starlink deployment. I feel like they should do that. So do we think we'll see it? I think we will. I'm going to go on record and say I think we will see it. Obviously, I don't know. I have no idea, but that's what I'm going to guess with. Let's see. All right, Mark, good question and good segue. Mark wants to know he just logged on. He wants to know what the trajectory is. All right. Well, so here's a look at our trajectory here for today. So we're launching in Boca Chica in Texas, obviously. But one of the questions he said, can we see it in New England? No, probably not going to see it up there. So we're heading mostly like southeast, or primarily because we're trying to stay away from land and population and things like that. Remember, Flight 7 kind of blew up a little bit. We don't want to go towards New England. A lot of land, a lot of people, a lot of things in that direction. So out here, following this trajectory here, you can really see that it's mostly ocean, and so that's where we're headed. I mean, there's a couple bits of land like right in this region here that's some debris from Flight 7 went to, but it's mostly ocean. And then when you get to engine cutoff, so engine cutoff of Starship is way back here, but once you can get to engine cutoff, then you're in your suborbital trajectory. So at that point, they can feel safe about going over land, like way out in here in Africa. I mean, it's still mostly over ocean the entire time. We even skimmed just the southern coast of Madagascar here. So it's really just southern Africa that we go over. And then we've got some hazard areas out here off the northwest coast or west coast of Australia. that's where Starship will actually touch down, assuming it gets there. But it'll be right out in this area here, and then hopefully, and then it should be daytime at that point. So we can see the Terminator line right here, the night and day Terminator line. We're just starting to get daylight into this area. We've still got 45 minutes until launch time. Then it's going to actually take an hour to get to the actual splashdown. So by that time, this Terminator line will be, you know, somewhere over here on the other side. So we'll actually land in daytime, which will be kind of cool. So that's the planned trajectory here. It's mostly heading southeast, basically. It's mostly east, but it's kind of like southeast, southeast, somewhere in that area. So that's our trajectory here for today. Good question. I did say that I was going to talk a little bit about weather as well. We probably ought to check in on the weather. Weather's looking pretty decent. It's a little bit breezy down there. It's, you know, got 15, 17 mile per hour winds down in Texas here. What happened to my map? There we go. So somebody's going to have to convert that to metric for me. But if we look at our radar, radar's pretty clear. We don't see anything on radar as far as storms. We look at our precipitation. There's not really much precipitation that's called for in the next 3 hours, so we're in pretty good shape. Look at cloud cover. We got a little bit of cloud, you know, overcast clouds in the area as of 4 p.m. If we fast forward a little bit, we're still 100% cloud cover there, so we may be punching through some broken or overcast clouds at that point, but that's not, as long as they're not big towering cumulus clouds, we should be okay. But our ground level wind speed's not too bad. If we look at our upper level wind speed, we go up here, we get a little bit faster, but it's still not crazy. You can see the bulk of the jet stream actually pushes north up here into like Oklahoma area. So it kind of dips down to the south, then comes way up here. So nothing crazy down here in the Texas area. We're only talking 70 mile per hour upper level winds, which is nothing too wild here on the wind chart. And we'll zoom out a little bit so you can get this fascinating view of our upper level winds here. If we switch back down to ground level winds are pretty calm. It's a little bit breezy. I mean, breezy for like human conditions. You know, we would consider this kind of a breezy day. Like nothing. Still not crazy, like you're not getting wind warnings or anything like that, but not too bad. So yeah, weather's looking pretty decent down there. And we'll show one other hazard map here. So here's a little hazard map as well that kind of shows these are all the published hazards like NOTAMs and NOTMARs to tell everybody stay out of these areas, because we got a launch happening here. So you can see some hazard areas out there. I don't know what this one is out here. This is another hazard. These are two more hazard areas out here. I'm not sure why we have that big gap or why there are two hazard areas way out here in the distance, but oh, you can't see those. Let me move it up here. These two out here, these two little hazard areas. I'm not sure why we have these two out here or why there's that big gap, but that's interesting. And then obviously if we come over here to the other side of the world, we've got these big, huge hazard areas. This is our reentry corridor here. So this is where things could get a little fiery, but hopefully our landing is going to happen right here. That's the planned landing. Is that pin right there. So that's the plan for today. And hopefully it all goes well and we don't have, and we don't have any major issues today. SpaceX should be going live any second here. We'll grab a couple questions before we check in with them. Oh, I do see, actually, they are live right now. So we'll get them up on the screen. We'll have to synchronize our watches. The countdown clocks. Because mine's about 30 seconds off here. So let me get them synchronized. Let's listen into what they're saying here for today, and I'll sync up I'll sync up the clock here.
Welcome to our first ever broadcast from Starbase's new Star Factory building. I've been waiting a while to say that. Super excited. We are just a little over 39 minutes away and counting down to a liftoff at 5:45 p.m. Central Time today.
Yeah, and if you were wondering, yes, that is the pad just behind us. Now, just over 1 month ago, we saw the second ever tower catch of the Super Heavy booster there at that pad, and that was also the first ever flight of the next generation of ship, which successfully lit all 6 Raptor engines and flew for several minutes before contact was lost.
That's right. We completed our investigation following that mission, made a number of hardware operational changes for today's flight. We're going to detail all of those in just a few minutes. Important to remember, though, progress in a developmental program like this one, it's not always linear. There's no comparison, though, for putting that flight hardware in a flight environment to learn as fast as possible. And as always, primary payload for Starship flight test campaign is data.
The objectives for today's flight will look very similar to Flight 7. We're planning to deploy simulated Starlink satellites and fly a range of experiments. We've moved a number of tiles from ship. We've removed a number of tiles from the ship for reentry testing. We will also intentionally be stressing the flaps during reentry so we can test the limits of ship before we get ready to attempt future ship catches. So lots of new testing happening today, and as always, excitement is definitely guaranteed.
And just checking on things at the pad real quick as we're under 38 minutes away. We are tracking to 5:45 p.m. Central Time liftoff. We've got a window all the way to 6:30 p.m. We have started prop load. You'll start to see those frost lines building up on both Super Heavy and Starship. We're not tracking any technical issues, any range issues, any weather issues from a launch at that 5:45 p.m. mark. So we are loading prop on the vehicles, looking good for a launch in just a little over 37 minutes. Now, let's meet today's vehicle on the pad. It's the world's biggest rocket, Starship.
Yeah, you see it there on your screen, but to get an even better sense of how big Starship is, let's start with the average size human, which is about 2 meters high, or a little over 6 feet. Towering over our human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, which is has the payload fairing attached, is double the height of the Millennium Falcon at 70 meters. And twice nearly the size of that is the fully stacked Starship, just over 123 meters tall. The ship is about 52 meters tall, and the Super Heavy booster alone stands at about 71 meters. So it's pretty big. And we do have plans to make the ship and booster even taller in the future, if you can imagine.
And Starship itself features 2 major parts. We've got ship, that's the fully reusable upper stage powered by 6 Raptor engines. And then we have the Super Heavy booster that's fully reusable first stage with 33 of those Raptor engines powering it. Super Heavy, the most powerful rocket ever flown. It's designed to launch, return, refuel, launch again with 0 refurb. And to make all of that happen, we also have Stage 0. That's everything else you see around it that enables Starship to fly. The tower, the orbital launch mount, quick disconnects, prop farm, everything. Stage 0 is also just as critical to achieving that rapid reuse as Starship itself.
Back on the rocket, the ship features 6 Raptors, 3 of them for sea-level engines and 3 for vacuum engines. Raptor Vacuum, or RVAC, is a similar design to the Raptor engine, but features a larger exhaust section and a larger expansion nozzle to maximize the engine's efficiency in space. It's also designed for vertical takeoff and landing on any hard surface, useful for when you're taking off from a place like Mars that's still waiting for its first launch tower.
And that ship is outfitted with 4 flaps that are used to control the vehicle's attitude during subsonic flight and to enable a precision landing. The 2 upper ones are right here. And then to achieve full reusability, the ship has to survive entry not just once, but multiple times, every single time we send it up and bring it back. It does that with its heat shield, which we iterate on every single flight as we're just building towards a heat shield that requires no refurbishment. The one today, it's still composed of those thousands of hexagonal ceramic tiles, and they're designed to insulate the vehicle during that atmospheric reentry where some of those temperatures spike up as high as about 2,600 degrees Fahrenheit. That's one of the real big things we're still working on. Rapidly reusable heat shield has never existed in history, so just continuously improving on it right now is just a key focus for all of these flight tests.
And then there in between the first and second stages is our hot stage. We saw that in action first starting on Flight 2. The hot staging maneuver is when the upper stage engines are ignited before the booster engines are completely cut off. With hot staging, the rocket never stops accelerating during separation. So it's actually more efficient than traditional stage separation, even though it sounds kind of crazy. You actually see it there on your screen now. That is one of the upgrades that we made on Flight 2, thanks to lessons that we learned on Flight 1. Several of the improvements and upgrades made for today's flight will unlock our ability to fly longer missions, something that we'll want to start doing, as we start doing orbital flights around Earth, and of course, eventually to Mars.
And
Hopefully
Ship
soon.
definitely had a lot of lessons learned on Flight 7, but Super Heavy Booster put on one hell of a show for our second ever return to launch site and catch. Marked our first reflight of hardware, shout out Engine 314, and it brought us a lot closer to full reuse. For more on that, get ready, Internet. We're going to be joined now by our buddy Chris out in Hawthorne. How's it going, Chris?
And thank you, Dan. And I couldn't
Chris
agree
Gebert?
more. Raptor 134 definitely started us down that path toward rapid reusability for the Raptor engines. And who knows? Maybe we'll see it again. Stay tuned. Welcome, everyone, to Hawthorne, California.
Chris used to be with NASA space flights. Met him down in Florida.
Starship's 8th flight test. Behind me, you can see one of our mission control rooms where engineers here in Hawthorne are assisting our flight control teams in Starbase, keeping an eye on various systems like Starship's avionics and, of course, those powerful Raptor engines that have quite a workout ahead of them today. Now, the Raptor engines you'll see and definitely hear today were manufactured right here in Hawthorne, California. And the engines on today's flight are all Raptor 2 engines, which is the same design we've been using for Starship's flight tests to date. And that includes all of the engines that have powered the 2 Super Heavy boosters back to Starbase for catch and recovery by
God, look at all those engines.
But here at SpaceX, we like to continuously improve our designs by eliminating the parts we don't need. We call this applying the algorithm, and that helps us simplify designs and drives us toward rapid, reliable reuse. And that's just what we're doing with our Raptor engines, like you can see here on your screen. I love this family photo of the Raptors because it really shows you the unprecedented step forward in rocket design that Raptor 3 is. And you can really tell that we applied the algorithm here, questioning the requirements for the engine, finding the parts we didn't need, and then optimizing for manufacturability and reuse. Now, one of the cool things about Raptor 3 is that it eliminates the large and heavy engine heat shields, which means that when we move from the Raptor 2 to the Raptor 3 engines on Starship, each Raptor 3 engine is going to save us about 1.1 metric tons of mass. And that's a lot of mass when you multiply that by 39 or more engines. So Raptor 3 will help us increase Starship's efficiency and as well as the amount of mass that Starship is able to deliver to space. And I gotta say personally, it's really exciting to be looking at the engine that will make life multiplanetary, beginning with Mars. But before we get to Mars, we still have a lot of important and critical development work to do. And it's flight tests like today's that help us do just that. So as we get ready for Flight 8, let's take a look back at last month's Flight 7.
All right. So they've got some music playing here, so I'll take this chance here to talk for a minute. You can watch some of the visuals, but I can't play the music here on my channel. But yeah, it's pretty exciting here. I didn't know Chris Gebert was going to be on the live stream. That's pretty cool. He used to be from NASA space flights. If you've been following the space world for a long time, he's a big name in the space media world. So now doing live streams for SpaceX that's got to be pretty cool. I don't think he's been on a live stream before, at least not that I recall. Anyways, so there were a couple questions. Somebody asked, and I don't know where it is, somebody asked how they police the hazard zones. And I wish I could find the comment. Somebody said, how do they police the hazard zone? In general, they don't. they don't police them at all. They're really just notifications to people that are like, don't go in this area. Now, like air traffic is definitely more controlled, air traffic control. So like commercial flights would not fly through the hazard areas. That's policed by air traffic controllers, giving assignments and telling planes where they can or can't fly. Most commercial air traffic is on an IFR or instrument flight rules flight plan, which means pretty much air traffic control is telling you where you are going. Versus like smaller planes, they're on a VFR flight plan or visual flight rules, and they pretty much decide wherever they want to go. You're generally not flying VFR over the ocean, so you're, unless you're going like to the Bahamas or like a smaller trip or something like that, but you're not flying over the Gulf on a VFR flight plan generally. So not a lot of that traffic around, but if they are, it would be up to them to stay out of those areas. If they're talking to air traffic control might tell them like, hey, you're in a TFR area, like you're not supposed to be flying there. But yeah, in theory, they could violate that and get in the way, and that would be a problem. But by that point, the policing of the air traffic, a lot of that's happening just in the immediate vicinity of the actual launch itself to make sure that you're not in the actual flight path in the immediate vicinity. And then after you get a mile or two past the launch site, Starship's up so high that air traffic doesn't really, it's not really a factor for Starship unless there's some sort of anomaly and then it's coming down. And then like really it's for your own safety to stay out of that area so that you don't get hit with debris coming down. I mean, if you're in the area and your VFR plane gets taken down because Starship blew up and you get hit with Starship debris, it's kind of on you. Same thing with like boats and things like that are in the NOTMAR sections. Like those are notifications like stay out of this area. If you don't stay out of the area and you get hit with debris, like that's on you. But they do police like the immediate vicinity of the actual launch itself. And those touchdown areas like where booster is initially targeting, they won't launch if those areas get violated. So they do kind of police the immediate area, but obviously they can't police the entire Gulf or the entire Atlantic Ocean or, the entire landing corridor and all that kind of stuff. So a lot of it is up to, the actual operators, captains and pilots and things like that, and to just stay out of those areas. Don't go in there. It's for your own safety. So, all right, let's listen back in.
Propellant leaks that we saw that eventually cascaded into fires and ultimately ended with loss of contact with the ship.
As part of our investigation, our team at Starbase took this flight's ship through a 60-second static fire on the Starship test stand, which is 10 times longer than any previous static fire. During this test, we cycled through multiple throttle levels. In fact, you can see that on your screen now. We cycled through multiple throttle levels on the engines to recreate different conditions seen within the propulsion system during flight. And we tested some hardware changes on fuel feed lines to the Raptor vacuum engines.
This gave us just the extra data that we needed to eventually implement new hardware that's installed in those fuel feed lines for the RVAC, the Raptor vacuum engines. Also tweaked a couple of other things like the temperature of the propellant as we're feeding it to the engines. Also the throttle level that we set for those engines during ascent. Having the ability to do a 60-second static fire, just one of the ways we're trying to expand our test capabilities here at Starbase. You want to test like you fly as much as possible. That just helps us to iterate even faster.
Yeah, exactly. The fuel feed lines to the Raptor vacuum engines, which are unique to this upgraded version of ship, look like large straws running through the oxygen tank. Today's vehicle has one of the hardware configurations we tested in that extended static fire because it showed it was able to minimize the harmonic response and lower its amplitude or strength.
We also took another look at where those fires broke out, specifically in what we call the attic. That's an unpressurized space between just the bottom of the ship's liquid oxygen tank and the top of those engine heat shields. Fires in that space resulted in a loss of vehicle back on Flight 2 and also on Flight 7. So we took some steps to make it more resilient to leaks in the future. To do that, we added a pretty hefty purge system. It's going to use gaseous nitrogen. It's pretty similar to the CO2, the carbon dioxide system we use on booster. It essentially just floods the zone with an inert gas to prevent a fire from ever starting. And then in addition to this, we increased the attic's natural fire defense just by adding some additional vent holes. That helps to keep the attic pressure as close to just vacuum as humanly possible as Starship flies into space.
And for the next generation of ship, we're running the algorithm. We're going to try and do the next best possible thing and delete some of the unnecessary space. So that ship will be using Raptor 3 engines, which will let us reduce the attic volume and eliminate the majority of joints that can leak into the space. In the end, what you're seeing take place with these changes is the core of our test program. We fly hardware all together in a real-world environment. We learn from the data, we make upgrades, and then we fly again. Ultimately, we fly to learn, and we're learning a lot.
That's right. Now, for today's flight test, we're going to be attempting to do everything we didn't get to do on Flight 7. We're still looking to get our first re-entry with this upgraded version of ship. Also intentionally trying to stress it to gather real-world data on just where the vehicle's boundaries are. So don't be surprised if it's not a smooth flight down to a landing for ship today. As always, it's going to start with liftoff, the 33 Raptor engines on Super Heavy igniting, lifting both it and Starship into its ascent, and it's going to power us all the way until hot staging.
Yeah, those engines on the ship will ignite while the ship is still attached to the booster. This will create that stage separation that we see there. Second stage will continue to go on its way. The booster will make a flip and come back here to the launch tower just behind Dan and I for hopefully what we will see the third ever booster catch.
Meanwhile, ship continues its ascent, gets into its suborbital place in space. We're going to have a test satellite deploy, pew pew, Starlink's firing out. And then we're also going to do a Raptor relight, relighting one of those sea level engines before we get to ship re-entry.
Troubleshoot by the state machine.
And the ship will continue through, make its entry phase that lasts for a few minutes.
I think we just got a hold call there. They just called hold on the countdown, which is...
And if some comms did just go out, we heard that an operator hold got in, so they are troubleshooting one issue. As we continue to move through prop load, we'll get some more details on what caused the hold. And if we start to reset to a new T0, we are still loading prop on the vehicle. So essentially putting that hold in means that if we get through everything and we hit that T-minus 40-second mark, we'll hold there and wait to clear the issue if we haven't cleared it at some point in the next 20 minutes.
Yeah, for those that are unfamiliar, that T-minus 40-second period is an opportunity to troubleshoot, unlike our Falcon timeline. So we do have a little bit of leeway. Yeah. Continuing on with today's plan, that ship will be making a soft splashdown in the Indian Ocean, as we have seen before. We are launching at 5:45 p.m. Today. This evening launch will allow us to have daytime views of the ship as it makes its splashdown. So, yeah, good news.
It's a lot on ship's plate, but we're still hyper-focused on finding all of those real-world limits of Starship. We want to be able to prepare to return ship to launch site and catch it. A lot of these recent upgrades are just made to enable that to actually happen.
Flight 7 premiered a huge block of upgrades to the upper stage to add more capability to Starship. And with Flight 8 today, we're hoping to get through a full flight. Starting us off, the forward flaps got a redesign. They shrunk in size and shifted toward the top of the vehicle and away from the heat shield. And that will significantly reduce their exposure to reentry heating. Also, by making Starship 2 meters taller, we added about 25% more propellant volume, along with propulsion upgrades such as vacuum jacketing of the feed lines, new fuel feed line system for Raptor vacuum engines, and an improved propulsion avionics module.
Yeah, ship got a little bit taller. That extra prop's going to allow us to fly those longer missions. We're not planning on stretching it a whole lot more beyond this in future ones, but then, you know, once we're flying the next version a lot, it'll be going. Just like the previous flight, a lot of tiles have been purposely removed. As again, we're trying to stress test all of the vulnerable areas, call this the missing tile test.
It's
Those tiles
interesting
are
how
removed
many
in strategic locations all across the vehicle, including critical areas like those tanks and over the flap seals, as we use this flight to just really push those boundaries. In addition to that, we have some metallic tiles, again, that are being tested, including one on the right of this animation that has some active cooling built in.
The vehicle's avionics also underwent a complete redesign with things like 4 upgraded Starlink terminals, combining Starlink, global navigation, and RF communications. You can see that location there on your screen. And on the sides of the vehicle, non-structural versions of the ship's catch fittings are installed to test the thermal performance, along with a smoothed and tapered edge on one section of the tile line to address hotspots that we observed during Flight 6.
And once more, we're back at testing some radar sensors on those tower catch arms. We did that last flight. We're doing it again as we look for some additional ways to measure the distance between the arms and the vehicle. Catching the ship's going to be pretty different from catching the booster. It does that flip right before, so your antennas are going to rapidly reorient. And so just having any extra sensors on the ground side, you're adding extra layers of control while the ship and tower talk to each other for a catch.
In another first, Starship will deploy 4 Starlink simulators. They are similar in size to our next generation Starlink satellites. With unparalleled payload capacity and full reusability, Starship will be able to deploy our more advanced V3 Starlink satellites, which will revolutionize global connectivity with Starlink all over again.
Each one of those Starlink V3 launches on a Starship is going to add about 60 terabits of capacity to the Starlink network. To give you some context, that's about 20 times the capacity of what we're adding with every V2 mini launch in a Falcon 9 right now. That's going to help us expand Starlink's network, expand its impact in the coming years as we expand that access to high-speed internet all around the world and eventually beyond. And the Starlink simulators that we're deploying today, they're going to be on the same suborbital trajectory as Starship. We expect them to demise as they enter in the atmosphere. And then Starship's trajectory itself looks very similar to our last several flights, splashdowns targeted in the Indian Ocean. And on top of all of that, we're also going to relight a single Raptor engine again while in space. We're just trying to get data on in-space Raptor burns. You're going to need those for deorbit burns when we're doing orbital missions, and eventually when we're doing missions way beyond Earth and we're on our way to Mars.
Yeah, so just like you said earlier, Dan, there's a lot on Starship's plate for today. But one of the hallmarks of these Starship flights are the incredible views that we get throughout the flight, courtesy of Starlink. Every day, we're working to expand the Starlink network both on Earth and in space. For how all this connects us to the big mission, let's head back to Chris.
Thanks, Kate. And as fans of Starship may know that Starlink enables us to bring you a lot of those unprecedented views, both from space and
So just, well, no, I'm going to listen to Chris.
plasma wrapping around Starship during reentry. So thank you to our Starlink teams who enable all of those amazing views and the information we get. Now,
ooh, look at this
in addition
view.
to the dozens of cameras on Starship itself, as you see on your screen
Oh,
here,
I thought that was a live view for a second.
Starlink camera kits deployed in the middle of the Indian Ocean.
That's not a live
as
view.
you're seeing from a previous flight. Starlink also allows us to connect our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas and the world. And that's all part of how it comes together to help us tell the incredible story of Starship both on and off the planet. So thanks to Starlink, Starship is now capable of streaming more than 120 megabits per second of real-time high-definition video and telemetry through every phase of flight. This not only provides those incredible views of reentry for all of us, but also the invaluable engineering data to help our engineers rapidly iterate across all systems of Starship. And all of that streaming data today will be put to good use with the more than 30 cameras that are on the vehicle for today's flight. Now, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of whom have never had connectivity before. As of today, Starlink is serving more than 125 countries, territories, and other markets, and has more than 5 million active customers and counting. But to meet the growing global demand for high-speed internet, SpaceX recently expanded its factory at Bastrop, Texas, and introduced Starlink Mini as well as an upgraded version of the Starlink standard kit. Here's our first ever look inside our brand new Bastrop facility.
Yep. All right. There we go. So I was thinking they were going to do some music there as well. So a couple things that I was trying as I was sitting here listening. I was trying my hardest to see if I could edit my countdown timer, because right now we're under a hold, but the hold is a little bit different than the way we typically see holds. So there's still the SpaceX stream still shows a countdown, and so I'm not really sure. I don't know. I suppose I could just keep the countdown running here, which could be fine. Because they are still counting down. They did call a hold over the comms, but in general, the way the Starship countdown works is that they're going to continue. They're going to continue the countdown all the way up until T-minus 40 seconds, and try to resolve the situation. So instead of just holding the clock right where it is, resolving the situation, and then restarting the clock, they just keep the clock running. And if they get to T-minus 40 seconds and they still haven't resolved it, then the clock will hold at that point. So I was trying to edit the programming behind my countdown clock to account for that and see if I could get it to say that it was holding, but also let it keep counting at the same time. But I don't know if I can do that fast enough while I'm actually still live streaming, but that's what's going on. So I guess I'm going to keep the clock running for now, just to avoid some confusion as to how much time we've got left to go. But we are technically under a hold condition right now. So it's kind of up in the air as to whether or not we'll actually see a flight. I was also trying, while they were talking, I was trying to figure out what they said, because I didn't, they were talking at the time, so I couldn't completely understand what they said the reason for the hold was. Like, I think they did give a reason, I just couldn't decipher it. So
Facility.
I'm going to try to check on that.
The infrastructure that enables us to do all of these amazing things, you've probably seen some changes recently around Starbase. Coming online this year is the second tower at Starbase, and this tower has redesigned chopsticks and is built to accommodate the next generation of Starship and Super Heavy. It will have a redesigned launch mount and flame diverter system built to be rapidly reusable and hardy enough to withstand hundreds of launches at a time. Now, over at the production site down the road, we're also building a new integration and refurbishment facility called Gigabay. And Gigabay, as the name implies, will allow us to process more Starships at the same time over our current megabays. But Gigabay isn't just for Texas. If that weren't exciting enough, we're also further expanding Starship operations into Florida, bringing production and launch capabilities to the Space Coast. As Starship flight testing, development, and launch cadence continues to pick up pace at Starbase in Texas, over in Florida, we're building a Gigabay as well. Gigabay will stand 380 feet tall and will provide about 46.5 million cubic feet of interior processing space and about 815,000 square feet of workspace. Now, as environmental impact statements continue for potential Starship launches and flights from both Launch Complex 39A at Kennedy Space Center and Launch Complex 37 at Cape Canaveral Space Force Station, we plan to complete the Starship launch pad at Pad 39A this year. And pending the completion of environmental reviews, SpaceX intends to conduct the first Starship launch from Florida from Launch Pad 39A later this year. Now, we're also interested in enabling Starship launches from Slick 37. And as part of this process, SpaceX has been given a limited right of entry for Pad 37 to conduct further due diligence at the site in order to move forward with the environmental impact study that's being led by the Department of the Air Force. Ultimately, we will have production, integration, refurbishment, and launch facilities in both Florida and Texas, driving the needed flight rate for Starship to help make humanity a multiplanetary civilization. And Kate, I could talk about this stuff for literally hours on end, but we've got a Starship to launch today. So how are things looking 11 minutes before launch here?
It's weird. Nobody on Twitter is even mentioning the hold call.
Go time. Quick update on range and weather. For the range, the area around the pad has been well cleared. This includes the land, air, and sea space. So all is clear on the range front. That also applies to over in the Indian Ocean. The sea and airspace has been cleared as well for ships re-entry. Once again, we are making a soft splashdown in the Indian Ocean. So just the buoy cams are out there, and we'll get some great videos once again. Weather, we have a 35% chance of violating the weather the weather constraints for launch today. So it's not perfect, but it's not bad. Visibility also not so awesome. We can see the tower here. We're 2 miles away from the launch pad, but visibility around the greater area might be a little challenging.
Yeah, in terms of the vehicle itself, so right now you can see we're almost done loading prop on ship, almost done on booster. If you tuned in and heard earlier, we did hear talk about a flight controller hold going in. So just a reminder, all that means is we wouldn't be able to pass that T-minus 40-second mark. They're literally talking about it right now on the loops that they think they've got the problem figured out. It was an issue on the booster where we think we will be clear by about the T-minus 2-minute mark, and we will be able to move right through that T-minus 40, hopefully.
All
So,
right, that's good.
Prop load continuing. We're not holding or anything yet, and we're expecting that issue to clear before we get to that T-minus 40 mark. This morning, though, we did all of the usual checkouts, aligned the navigation systems, did all of our booster and ship tank purges, got them ready for prop load, chilled down the pad, which you can see all the cryo right
It's
now.
chilling.
Things are pretty chilly out
Well,
there.
flaps are moving.
Prop load's been
Flaps
going.
are moving.
We just did a flap check out. We also do a wiggle check out on the chopstick arms as well. We are going to continue loading prop for about another 6 minutes. We're going to close ship at about 3 minutes, 20 seconds before launch. Booster just about 30 seconds later. So we've had at least one issue that we're still working in the background, expecting that to clear before we hit that kind of that hold gate at T-minus 40 seconds, and looking good.
Yeah, so bottom line, things are looking good for liftoff here in just under 9 minutes. We're now at, looks like 8 minutes and 49 seconds. So everything's looking green so far.
Yeah. Before we get any closer to liftoff, I need to shamelessly plug Starbase. I'm one of just a couple thousand people who work here, soon to be the newest city in Texas at Starbase, and we're the largest employer in the area. We're always hiring, so visit spacex.com/careers, see all the openings. It's where the future's being built, and it's a future we can all be pretty excited about. So yeah, come work here. Anyway, back to our regularly scheduled program. Let's launch a rocket.
All right, so we're coming up to 8 minutes until liftoff. As we mentioned before, flight controllers are already on console. They're located in our Ad Astra Launch Control Center, about 6 miles away from the pad. But they will soon be moving here with us to Star Factory. So a lot of excitement around that, certainly growing.
Yeah, and again, general status check. We're continuing to progress. We're under 8 minutes away. We're tracking an issue with booster. We're expecting that to clear. Still looking good for launch. Speaking of booster, let's talk about catching one.
Absolutely.
The tower's 2 giant robotic arms that lift and stack Starship on a Super Heavy for final integration ahead of flight. We also use those to catch. It means we don't have any landing legs in the booster. Makes the booster lighter. Means we can throw more payload into space.
Exactly. Following liftoff and after the 2 stages separate in flight, Super Heavy will return to the launch site, the same exact launch site that it lifted off from, reignite its engines to slow the vehicle down. Here we see playback from a previous booster catch. I believe that was our first booster catch. The vehicle will slow down, tower arms will come out and catch the booster.
And just like the last few times, literally thousands of different vehicle pad criteria have to be met before we bring a booster back and try to catch it. We need healthy systems on Super Heavy, on the launch tower, and we need that final manual command from the mission's flight director for the day. If that command isn't sent before we finish the boost back burn, or if any of those automated health checks kick us out, the booster defaults to a trajectory, takes it to a landing burn and a soft splashdown in the Gulf.
Yeah, we have said it multiple times before, but it still holds true today. We accept no compromises when it comes to ensuring the safety of the public and our team, and the return will only take place if the conditions are right, and there are many of them. So there's a chance that we may not get to catch the booster today.
Yeah, and one aspect to the return and the catch of that booster is the audible sonic boom in the area around the return location. That happens as the booster's slowing down from supersonic speeds. It's similar to sonic booms that were heard during the return and landing of NASA's space shuttle for anyone that was in Florida for those.
Sonic booms like these are unique to vehicles returning from space and are one of the hallmarks of reusable systems like our Falcon 9 and Falcon Heavy vehicles. The general impact to those in the surrounding area of a sonic boom is basically a brief thunder-like noise. And I've heard sonic booms before, but I got to experience my first in-person Starship sonic boom on Flight 7, and I can confirm it's pretty fun to experience.
Paul, listen to this. Oh my God, that's the coolest sound ever. Every time that crack comes from, so cool.
What a way to announce a returning space vehicle's return for reuse. Now, here in California, as you can imagine, the excitement is growing here. The crowd is growing. Kate mentioned our flight controllers in Ad Astra in Texas. Here in Hawthorne, we also have controllers on console in Mission Control, helping those teams in Texas monitor Starship's various systems, including the avionics and those 39 Raptor engines that were built right here in Hawthorne. Now, with 4 minutes, 30 seconds to go, Dan and Kate, how are we looking for a launch today?
So we are still looking good. We're just about fully topped out on propellant on both vehicles. The closeout's going to be coming up in about a minute on ship, and then about 30 seconds later on the booster. We are still hearing chatter in the background about the booster issue that we're tracking. We may still be able to pass the hold, but if we need to hold at T-minus 40 seconds, we have several minutes that we can hang out there and work to just kind of troubleshoot those final issues before we get the go. Once we're fully loaded on prop, which is coming up soon, we've got just shy of 11 million pounds of liquid oxygen, liquid methane on both of those stages. And then once we're done, we're going to see that we're going to hear the ground lines do what's called pushback. So all of that propellant gets pushed out of those lines back to the tanks, clearing the pad for launch.
Now, the only problem that I have, so they're talking about that booster issue. They were expecting to hopefully have it cleared by T-minus 2 minutes, which are coming up on. It sounded a little more concerning. He sounded pretty unconcerned about it the last time he mentioned it, but this time he sounded like we might be bringing this to all the way to the 40-second mark. You know, the thing I hate about that is that it's really hard for me to update that timeline if they adjust the launch time like 40 seconds prior to launch. So we're gonna try to keep up with it the best we can. Hopefully we don't run into a hold condition. But because at this point we should be boosters completely fueled right at the T-minus 40 second mark. That's really the next milestone is that vent down.
And if we can proceed again to T0, but that's only in certain situations.
All right, so we're just about 2.5 minutes away. We do have a couple of things like if we hit T-minus 10 seconds and you see water start flowing out of the deflector, that is a reason for us to scrub for the day. Is that's once it's turned on, it doesn't turn off, and then we'll have to refill the tanks on both the water farm and the prop farm. Our team's gotten really, really good at refilling stuff really quick, so we can reposition for about a 24-hour recycle if we need to.
Yeah.
But
Speaking of
we're
things,
coming up. We're coming up just under 2 minutes away. Now hearing we might hold at that T-minus 40 second mark while they still talk through a couple of troubleshooting steps. But again, if we hold there, we can hold there for several minutes, even with all prop fully loaded on the vehicle, before we can release the hold and decide to move forward.
Well, we're less than a minute away to finding out if we're going to launch here. It was not sounding good. Bear says so far no hold. They actually already called the hold.
Keep your eye on the clock.
Like half an hour ago, so they have to release the hold at this point.
Hold there. It's not a rocket launch unless you're talking nonstop in the background until right before you lift off.
Once again, if we hold at T-minus 40 seconds, we have an opportunity to hold there for several minutes. This is unique to Starship. We don't have this ability on Falcon.
As we're about 15 seconds away, we did just hear
10 seconds.
We are going to hold at T-minus 40. So look for the clock to pause when we hit T-minus 40 as they finish troubleshooting. And then we'll let you know as soon as we start hearing more. And if that clock's when that clock's gonna start rolling. So holding at T-minus 40. So the team's talking in the background, still troubleshooting. And we can hang out here for a couple of minutes.
Well, we're on a hold. It's gonna make updating the clock like really difficult because it becomes.
Right, it sounds like we cleared the issue on the booster. We're now holding for a late breaking issue with ship. So they're talking through that right now.
Dan, you mentioned things that we've gotten really good at. It's incredible to think that we just stacked this vehicle earlier this morning, and
Could be
we're
good
already,
news.
you know, through prop load. Prop load's pretty much complete and ready to go. It's a very slimmed down timeline.
Yeah, this by far will be our fastest. We stacked the thing for the first time ever with these vehicles less than 24 hours ago. We really want to get to a point where we can, you know, fly rapidly, fly as quickly as possible, and so this is definitely a case to try and push that forward. No wet dress or anything like that with these vehicles.
Absolutely. And should this booster come back for a successful landing, you were talking about the rapid part of rapid reusability. This booster may fly on a future Starship flight if we're able to catch it and bring it back online.
Now, I don't know how long they can hold this for. I mean, I think we can hold for quite a while, but like launch window wise, we have until 7:30 p.m. Eastern time, 6:30 Central. So we still got like 45 minutes in the launch window. Vehicle is fully fueled. They're able to hold this with the vehicle fully fueled, which is different than Falcon 9. Falcon 9, if you call a hold, the minimum time frame, you have to recycle the clock to a minimum of T-minus 15 minutes anytime you call a hold below the 15-minute mark. But Starship doesn't have that, so Starship can actually hold fully fueled like this at 40 seconds for at least minutes. I don't know how many minutes. I'm not sure if we know the exact answer of how long it can hold this or remain in this condition, but it's at least for, you know, a few minutes. I don't know how long that's going to be. So we've been in the hold for about 2 minutes now. And we'll see how long that stays for. I don't know. The question really becomes, or the question that I have that I don't know the answer to is, at what point would we have to like recycle the clock and back up a little bit? Or can we just hold this at 40 seconds all the way until the 45-minute mark? I mean, because they can kind of just keep on, like, they haven't actually done the vent down yet. I know it says vent down is done on my clock there, but they haven't actually done that yet. They would do that once the hold is released, but they theoretically could just still keep topping off the vehicle with fuel and just keep her going until that hold gets released. But right now, we're just kind of hanging out waiting. They did say, so there was a booster issue. They didn't hear exactly what it was. There was a booster issue that they originally were holding the clock for. They cleared that, and now it said they were doing some like final checks or something like that. So I'm not sure exactly what they're doing, but that's where we stand right now. We're just kind of holding and seeing what happens. And the weird thing, or the crazy part, is that if the hold gets released, like, you know, it's not like you can go anywhere, because if the hold gets released, we're launching 40 seconds later. So, but this is the first time they've actually held the count, I think, since Flight 2, which is kind of amazing, to be perfectly honest, given that it's still a
All right, if you're just tuning in, we are still holding
very experimental vehicle.
40-second gate. We cleared an issue on the booster that we were working up until the hold, still working one on ship, and team still continuing to discuss in the background. We can still hold here for several more minutes. If we're not able to resolve the issue or find a workaround, then we would have to essentially scrub and stand down for the day. If that does happen, we can go as early as tomorrow, but that clearly depends on what work we might need to do to fix any issues. So just obviously stay tuned. But right now, we're a little over 5 minutes into this hold today. We've got a couple more minutes that we can hold at T-minus 40 before we have to kick out. Essentially, looking at a lot of those propellant temperatures on both vehicles, you want those to stay in pretty specific ranges for engine startup and things like that. That's what generally drives how long we can hold at T-minus 40. So still hanging out. As soon as we hear an update on the ship, we will let you know.
Yeah, so we don't want to... It sounds like they cannot hold, for the entire 45 minutes. That seems like a stretch because you're... Sounds like maybe given the size of the vehicle, the amount of propellant they're using, like the warm-up of the actual propellant tanks is probably a little bit slower. And so they...
It's starting to sound like we might have a decision real soon. All right, you see the clock rolling.
Oh,
It is time
we're going.
to go for launch.
Here we go.
So, 30 seconds to
Yeah,
go.
baby.
Oh. And we just heard
no.
a hold. So we kicked. Psych. No. So we did kick out back to the T-minus 40 hold.
Well, bummer. We're back to holding. Well, we almost got there. We got a little bit of excitement. And
All right, so as we started counting back down, we did trip a few more holds automatically from the booster itself. So we are now going to hang out here again at T-minus 40. They've got a couple more troubleshooting steps that they can take. If we're able to get through that, we can start counting down again. If not, we could always offload and try again on either tomorrow or another day. But right now, we're not done for the day yet. Still holding at T-minus 40 seconds. And as soon as we hear some more or start seeing that clock move, you will know if we're going to go for our launch attempt today or if we just try it again another day. So keep listening in, and we'll have an update shortly.
we were so close. I thought it was happening. Oh, we're stuck here. Well, they didn't scrub for the day. We're just in a hold, so that's good news. But now we're just waiting to see what happens.
Go.
Oh, what's that? All I heard was go.
All right, and we did just hear the call. We are going to offload for today, so we had a couple of holds trip as we started counting down from T-minus 40 again, and it's not something we can change with small config tweaks, so we are going to offload our prop and then try again another day. So we're able to fully tank the vehicle. We're unable to lift off today, but just because we don't go today doesn't mean we're not going to go tomorrow or one of the days coming up. So we are going to start offloading all of that propellant on the booster and the ship. As we talked a little bit earlier, we can go as soon as 24 hours later. We won't know that for sure until we dig into everything that kicked us out of our attempt today. So obviously just keep an eye on all of our updates. So we are expecting could be about 24 hours, but we will definitely let people know.
Yeah. So we want to thank everybody for tuning in. Unfortunately, we would have liked to lift off today, but the teams are doing the right thing and standing down while we troubleshoot, and we'll share more information as it becomes available, including when our next launch opportunity is. So be sure to keep an eye on our SpaceX account on X, and as I said, we'll share more information as it becomes available.
All right. Thanks all for joining us today. We'll see you at the next attempt.
All right. Well, that's a bit of a bummer. Launch scrubbed for today. Before everybody jumps out, maybe hit the like button. Consider subscribing before you leave. But if you're going to stick around for a minute, we'll just wrap up for just a second here. Was it like 22, 24 minutes before launch, they identified some sort of problem with the booster. Then they reportedly got that resolved, had some other last-minute checks they needed to do. Then they seem to have gotten those resolved. They restarted the clock again for a brief moment, and then they had some automated things trip and hold the count as well. So they checked into those, and apparently it's not something they're going to be able to fix quickly. So it's a scrub for today. Something wrong going on. So Arturo Gary over on Facebook says cancel because of weather, because it's too windy. No, it's actually not a weather issue. The weather was go, but it's something with the actual vehicle or the launch hardware itself. Could have been that tower. They didn't really specifically say what the final scrub call was. So we'll probably find out shortly on they'll probably post an update to say exactly what caused the automated hold there at the end. And then we'll find out what the issue was. So they potentially could go as early as tomorrow. I really hope that they do not go tomorrow, because I probably cannot live stream it if they go tomorrow. I've actually got a lot going on the whole rest of the week. Today was ideal. I had nothing going today. Like, let's launch it today. This would be perfect. But I think I'm definitely out for tomorrow. But if it's another day, we'll see if we can make something work. Not sure what I'll be able to do, but we'll see what happens. So scrub for today. No Flight 8. But, scrubs are better than booms. So we don't want to see anything wrong, bad go wrong with the vehicle. Obviously, last launch was in January. It's like it was a 2-month wait to get to this point. Ideally, they want to try to do this many, many times so they can iterate and improve. And every time you have a big anomaly like a Flight 8 or Flight 7 explosion kind of thing, it takes them a while to get going again, because you got to do an investigation, make sure you fully understand what went wrong. So yeah, better to just scrub, wait a couple days, than to have a big boom and have to wait 2 months to do your next flight. So yeah, that's what we did. That's all we got for today. It's going to be no launch. Our guy says is amazing wet dress rehearsal today. Well, yeah, that's pretty much what we got to see. Mike says, thanks. Appreciate you joining us here today. Robert said, thank you very much for the super chat. Robert says, thanks to the show. We'll see you next time. Yeah, hopefully it'll be maybe in a couple of days. And then I'll be able to jump on and do it again normally. Because I don't want to miss this one. I'm excited for this one. So we'll see what happens. Tracy, one of our channel members. Thank you, Tori. Hope to see you soon. Eagle Soars USA, another channel member, says, thanks. Appreciate it. Thetis Legacy, another channel member, says, stay strong, Space Lobster Nation. We're all staying strong. We're going to wait for the next mission. So, all right. Well, bummer, everybody. Sorry that there's no launch today, but appreciate you all hanging out and chilling with us for a bit. We'll try to do this again real soon. And of course, my schedule gets a little not so chaotic about a month from now. So hopefully I can try to be around a little bit more coming up soon. So, all right. Well, that's going to do it for me. We'll try again another day. My name's Tori. This is Overlook Horizon. I'll see you next time. Goodbye, everybody. See ya.